Welcome back, everyone. Today, we're diving into some of the most insane engineering mistakes ever made. You know, those moments where someone messed up so badly that it became a cautionary tale for, the rest of human history. We're talking bridges collapsing, buildings toppling over, and even a few explosions thrown in for good measure. These disasters were so bad, they became legendary. So buckle up, grab your engineering hats, or hard hats, depending on how nervous this makes you, and to get ready to learn from the mistakes of the past. Let's get started. Let's kick things off with a classic engineering fail. The Tacoma Narrows Bridge collapse. Nicknamed Galloping Gertie, it opened in July 1940, impressing everyone for 4 months. The bridge was way more flexible than anticipated, swaying even in mild breezes. On November 7, 1940, a windstorm hit. The bridge started to ripple and twist, then, snap, it collapsed into the Puget Sound below. Sadly, a Cocker Spaniel named Tubby didn't make it off the bridge. The footage is wild, like something out of a disaster movie. Next up, we're traveling back in time to 1628 to talk about a ship so top-heavy it makes a double-decker bus look stable. I'm talking about the Vasa, a Swedish warship that didn't quite make it out of the harbour on its maiden voyage. Imagine spending 2 years building a massive warship decked out with cannons and intricate carvings. The Vasa was supposed to be a symbol of Swedish power and dominance on the high seas. They even painted the gun ports red just to intimidate the enemy. So, on August 10th, 1628, the Vasa set sail from Stockholm harbour. Crowds lined the shore, cheering on this magnificent vessel as it embarked on its maiden voyage. There was just one tiny problem. The Vasa was about as stable as a newborn giraffe on roller skates. You see, they'd built it too tall and top-heavy, and they hadn't put in enough ballast to counterbalance the weight of the cannons and upper decks. So, as the Vasa caught a slight gust of wind, it began to tip and tip and tip, until it finally rolled over and sank, just 1,300 meters from shore. Can you imagine the looks on the faces of the people who had gathered to watch this mighty warship set sail? Talk about an epic fail! Let's be honest, you can't talk about engineering fails without mentioning the Leaning Tower of Pisa. I mean, it's literally famous for being a mistake. Construction on this iconic bell tower began way back in the 12th century, in 1173 to be exact. And right from the get-go, things started to go wrong. You see, they built the foundation of the tower on soft ground, a mix of clay, sand and shells. Not exactly the most stable stuff to build on. So, as they started adding more levels to the tower, it began to lean. And I'm not talking about a little bit of a tilt here. This thing was really starting to go for it. By the time they reached the third story in 1178, the lean was noticeable enough to cause concern. But did they stop construction and fix the foundation? Nope. They decided to just keep going, figuring they could compensate for the lean as they built higher. Spoiler alert, it didn't work. The tower just kept leaning more and more. Amazingly, it took almost 200 years to complete the tower, finally finishing in 1372. And by then it was leaning so much that people were worried it was going to fall over completely. Chapter 4. This next one is a real tragedy. On July 17th, 1981, a dance competition at the Hyatt Regency Hotel in Kansas City turned into a nightmare when 2 of the hotel's suspended walkways collapsed. Picture this. It's a Friday night. The atrium of the Hyatt Regency is buzzing with people. Music is playing and everyone's having a good time. Suddenly there's a loud crack. Before anyone can react, the 2nd and 4th floor walkways come crashing down onto the crowded atrium below. The collapse killed 114 people and injured over 200 more. It was a devastating event that sent shockwaves through the engineering community. What went wrong? Well, a seemingly small design change during construction had doubled the load on a critical part of the walkway support system. It turns out that even a small change in a design can have catastrophic consequences if it's not properly accounted for. Chapter 5. The Hindenburg Disaster is one of those events that's forever etched in our collective memory. On May 6, 1937, the German passenger airship LZ-129 Hindenburg caught fire and crashed in Lakehurst, New Jersey. The airship, a symbol of German engineering prowess, was attempting to dock at the Lakehurst Naval Air Station after a transatlantic flight from Frankfurt, Germany. As the Hindenburg approached the mooring mast, a fire broke out, engulfing the airship in flames. Within seconds, the entire structure was consumed by fire, crashing to the ground below. 36 people lost their lives in the disaster, which marked the end of the airship era. While the exact cause of the fire is still debated, the most likely explanation is that static electricity ignited the airship's flammable hydrogen gas. It's a stark reminder that even the most advanced technology can be vulnerable to unexpected events. Chapter 6: The Space Shuttle Challenger. Disaster is a stark reminder that even the most meticulously planned space missions can go horribly wrong. On January 28, 1986, millions of people around the world watched in horror as the Space Shuttle Challenger broke apart 73 seconds into its flight. The shuttle, carrying 7 astronauts, disintegrated over the Atlantic Ocean, off the coast of Cape Canaveral, Florida. The investigation into the disaster revealed that the cause was a failure of 2 rubber O-rings in a joint of the right solid rocket booster. The O-rings, which were designed to seal the joint and prevent hot gases from escaping, had become brittle in the unusually cold temperatures on the morning of the launch. The failure of the O-rings allowed hot gases to leak from the booster, leading to a catastrophic structural failure. The Challenger disaster was a national tragedy, and it led to a 2-year grounding of the Space Shuttle program. Chapter 7: A Nuclear Nightmare. The Chernobyl Nuclear Disaster. The Chernobyl disaster, which occurred on April 26, 1986, is considered the worst nuclear accident in history. The disaster happened at the Chernobyl nuclear power plant in Ukraine, which was then part of the Soviet Union, during a safety test on one of the reactors. A combination of design flaws in the reactor and a series of operator errors led to a runaway chain reaction, resulting in a massive explosion and fire. The explosion released a plume of radioactive material into the atmosphere, contaminating a vast area around the plant. The disaster had a devastating impact on the environment and human health. 31 people died in the immediate aftermath of the explosion, and thousands more have suffered long-term health effects from radiation exposure. The Chernobyl disaster highlighted the importance of nuclear safety and the potentially catastrophic consequences of human error. Chapter 8: An Ocean of Oil, the Deepwater Horizon oil spill. On April 20, 2010, the Deepwater Horizon oil rig, located in the Gulf of Mexico, exploded, killing 11 workers and triggering the largest marine oil spill in history. The explosion, caused by a blowout of methane gas from the well, unleashed a torrent of oil into the Gulf, spewing an estimated 4.9 million barrels of crude oil into the ocean. The spill had a devastating impact on marine life, coastal ecosystems, and the livelihoods of people living along the Gulf Coast. The disaster highlighted the risks associated with offshore drilling and the importance of environmental protection. A dam of despair: the St. Francis Dam failure. The St. Francis Dam, located in California, was a concrete arch dam completed in 1926. Just 2 years later, on March 12, 1928, the dam catastrophically failed, releasing a massive wall of water that flooded the valley below. The flood killed over 400 people and caused widespread destruction. The failure of the dam was attributed to a combination of design flaws and poor construction practices. The disaster highlighted the importance of sound engineering principles and the potentially devastating consequences of cutting corners. Chapter 10: A House of Cards, the Lotus Riverside complex collapse. In 2009, a 13-story apartment building under construction in Shanghai, China, suddenly collapsed, shocking the world. The building, part of the Lotus Riverside complex, toppled over in its entirety, leaving a pile of rubble in its wake. Miraculously, only 1 worker was killed in the collapse, as the building was still under construction and largely unoccupied. The investigation into the collapse revealed that the cause was a combination of poor construction practices and inadequate foundation support. The disaster highlighted the importance of building codes and regulations in ensuring the safety of structures. Lessons learned. The importance of engineering done right. Thanks for watching. If you enjoyed this video, make sure to give it a thumbs up and subscribe for more fascinating content. We've seen some crazy engineering fails today, from bridges dancing in the wind to buildings collapsing under their own weight. But the most important thing to remember is that these disasters offer valuable lessons for engineers, builders, and anyone involved in creating structures. By learning from these mistakes, we can help prevent similar tragedies from happening in the future. So next time you're walking across a bridge or standing in a tall building, take a moment to appreciate the engineering that went into making it safe and sound. See you next time. See you.